Okay, so let's do some sample problems with pH and pOH. I ran just a little bit out of time, but that's okay. I'd rather get through them correctly. All right, if we want to find pH and pOH of each of the following solutions of 25 degrees Celsius, so let's start with this one. We can use the pOH equation. pOH is equal to the negative log of the hydroxide ion concentration. So pOH is going to be equal to the negative log of 1.0 times 10 to the negative third. Okay, so our pOH rather, is going to be equal to 3.00. 2 sig figs, 2 decimal places. I hate this rule. I don't get to change it. It's just the way it is. You also do not need a unit. Now, in order to find the pH, well, all I'm simply going to do is take 14.00 minus 3.00 and get 11.00, okay, which would also make this a basic solution. Now, if you do the math and you try to plug this into your calculator now remember, hydrogen ion is going to give us pH is equal to the negative log of the hydrogen ion. So pH is equal to the negative. Now, don't try to put negative number in your calculator because it's going to say error. What you need to do is find the log of the number first. So go ahead and find the log of 1, and if you're good at math, you're going to know it's equal to 0. So I can't, that was kind of a bad example. Let me go back over here for a second. If I type in 1.0 times 10 to the negative third and I take the log, it's going to give me negative 3. And so then I change that to positive 3. Okay, so there you go. Now, when you plug this one in your calculator, you're going to get 0. Okay, now remember, it's not wrong. 0.00, we can have a real discussion here on sig fig since there's no numbers. If the pH is equal to 0, it's just a really stinking strong acid, okay, which 1 molar, that's there. So then my pOH value is going to be equal to 14.00. Okay, so you just, again, subtract the difference between those. All right, so let's use Kw then to solve for some of these. So if Kw is equal to 1.0 times 10 to the negative 14th, it always is, we can also do it this way. So the hydrogen ion concentration is 1.0 times 10 to the negative 9th. Negative log is 1.0 times 10 to the negative 19th. pOH is going to be equal to 5. Is it acidic or basic? Well, it's going to be basic because you always look at the pH value to determine if it's an acidic or a basic solution. Okay, so again, if we come back to this one here for just a second, you always look at the pH value. pH is 0, so that is really, really, really stinking acidic. Okay, and again, you looked at the pH down here to get it to be basic. Okay, so this one's going to be basic. One more, I believe, here. pH of a solution is 5.77. Calculate the pOH, the hydroxide ion, and the hydrogen ion concentration. So again, you can work backwards here. pOH is equal to 14.00 minus 5.77. It's going to be 8.23. Your hydroxide ion concentration, again, if you're not super familiar with these buttons on your calculator, just practice to make sure you can get the right number. Okay, it's 10 to that value in order to work backwards from the log equations, rather. All they did here is remanipulate the pOH values as being the negative log of the hydroxide ion concentrations. They've just already done the math. So then hydrogen ion, we're going to flip that one around, take our pH value, and get 1.7 times 10 to the negative 6, acidic or basic. Again, we look at the pH value. Since the pH value was 5.77 and that was less than 7.00, we get acidic. Okay, I'm going to stop there and then we will get going with how to find those Ka values.